Let's take a look at some examples for finding the mean, the variance, and the standard deviation of a discrete probability distribution. The probabilities that a player will get 5 to 10 questions right on a trivia quiz are shown below. Use technology to find the mean, variance, and standard deviation for the distribution. Since we are doing a discrete probability distribution, we don't have the raw data. This is a distribution. It's actually a population, not a sample. We cannot use the mean and the variance and the standard deviation built-in functions to Excel or Google. We cannot use the same process of adding all the values up and dividing by how many we have to find the mean because our values have associated probabilities with them. Since we've done previous examples by hand for the mean, the variance, and the standard deviation, we're going to use technology for these next two examples. Okay. Here I have my Google sheet, my probability distribution along the top rows, and I want to start out by finding the mean. Now again, I can't type in equals average, select the data. This isn't data, it's a table. So we're going to set up x times p of x. We can do this in a couple of different ways. We could do it all in one step, or we could come up to the third row and just do this times that, so x times p. We take that value, drag it across so that it's all the way across, and then in our last one, add them up. 7.4 is our mean. So let me show you how to do it all in one step. I think it's a little bit easier the way that I just did. X times p of x along the bottom, and then at the end add them up. But if we wanted to do it all in one box instead of having the extra row down there, we would select x times p of x plus x times p of x plus so forth until we get all the way down to the last one. Extra plus sign. And we get the same value. So 7.4 is our mean, or expected value for our discrete probability distribution. So we can also label it as expected value. To find the variance, we need some more. So I'm going to copy my table. I'm going to use the first way that I did it, where I'm utilizing the rows. When we did it by hand, we used a column form, so giving you a different perspective for this. Below our table, we need x squared. So I can go ahead and type that in, x squared, 25, 36, 49, 64, 81, 100. And then in the next row, x squared times p of x. So we'll do x squared times p of x. We're currently trying to calculate the variance. And then I'm going to drag that calculation over. Now we're supposed to add up the x squared times p of x. So let's type in sum, try this again, sum. And notice that it's got a suggestion based on the data B10 through G10. Those are the exact values that I need. So I'm going to hit enter. Let Google autofill it. Excel's not quite that savvy. So just know that you may have to select the data for Excel. And we get 56.6, but we're not done. Flashing back for a moment, our formula for our variance is that sum of x squared times p of x minus the mean squared. So we have this extra calculation we need to do, minus the mean squared. So my mean is 7.4. I'm going to put this in here, 7.4 squared. And then my variance, let's label this here, is going to be the sum minus the mean squared. And we get 1.84 for our variance. To get the standard deviation, we're just going to take the square root. SQRT, the value right above, 1.36, and we can decrease the decimal places if I select on the correct one. Our data are in whole numbers. The x, our variable, is a whole number variable. So we ideally really need one decimal place, but make sure to read carefully when you're working on the homework, that you follow the rounding directions in the homework. And there we have our standard deviation. So coming back over here to our problem. Our mean was 7.4 questions. Our variance was around 1.8. And our standard deviation was 1.4. On average, a player will answer 7.4 questions correctly if they repeat this trivia quiz over and over and over again. We can use this information to also determine if a claim is believable, if we have an outlier in a situation. Let's check out the next one. A pizza shop owner determines the number of pizzas that are delivered each day. If the manager stated that 45 pizzas were delivered on one day, do you think this is a believable claim? We're going to find the mean and the standard deviation and then calculate the z-score of 45. If the z-score is greater than 3 or less than -3, we would consider that value an outlier. Remember, 3 standard deviations away from the mean, and it's considered an outlier. So let's try this out. Again, over in Google, we have this data, same table as before. And we'll start out by calculating the mean. Equals x times p of x. I'll drag that over. And then I'll add them. And I get 37.1. Okay, so that's my mean. For our variance calculation, we need x squared and we need x squared times p of x. So I'm just going to make 2 more rows and leave my table above. X squared, and drag it across. And then x squared times p of x. And we'll drag those across. We need to add up the x squared times p of x. And then we need to square the mean. Square the mean. And subtract them. Variance is going to be the sum minus mean squared. And we get 1.29. Standard deviation, we're going to take the square root. 1.13. So on average, we would expect to deliver 37.1 pizzas. Let's try this calculation. So let's just do this in Google. So we want the z-score for 45. So for 45, we take the value 45 minus the mean 37.1, close the parentheses, divided by the standard deviation. And I'm just going to leave it unrounded. We get 6.96. Wow. Okay, let's write down some stuff that we did. Okay, so we just calculated the mean, 37.1. Our standard deviation was 1.135, which would be 1.14 if we were rounding to 2 decimal places. With the x, we normally would round to 1, but the rounding, it varies so widely. There is a standard, but it's not always followed. It's one of the things that makes teaching statistics for me difficult, is that some of the rules aren't followed, or there are different rules for the same thing, like on our quartiles from before. So it just makes for ambiguity, and I'm not a big fan of ambiguity, but sometimes it's okay. So here, 1 decimal place is kind of minor in the whole grand scheme of things. So let's keep going. We're going to calculate the z-score. We did 45 minus our mean. Oh, let's put the formula in. So value minus mean over standard deviation. Discrete probability distributions are populations, so we're going to use our population notation here. And then we would plug in the values, 45 minus 37.1 divided by 1.14. When we did this in Google, we got 6.96. That is very much bigger than 3. So 45 would be considered an outlier to this set. A pretty big one. 6.9, it's almost 7 standard deviations away from the mean. That's tremendous. Because it's so far away from the mean, we say that this is unlikely to be true. It's not that it's not true, it's just really difficult to believe it. We'll learn a little bit more concretely in Chapter 6 just how a value that's far away from the mean has a very, very small probability of actually occurring. So the fact that this 45 is 7 standard deviations away from the mean, it actually has an extremely low probability of actually occurring because it's so far away. So since 45 is an outlier, we would say it's likely not believable, but it does not mean that the manager is lying. There could have been something that happened that day, a big celebration, a big party of some kind, lots of people gathering together. So there's a possibility. But because the standard deviation is so large, it's probably not believable.